Hello all, I'm Vishal Pallagani, and now we'll be going through the code of Plansformer for Inference. So you need to do the usual of going to the runtime, changing the runtime to a 100 GPU, and making sure you get connected to it. So once you are connected, you can see a green tick mark over here, which I've already done. And then let's go through the code. We'll be installing Transformer from Hugging Face and Sentence Piece Tokenizer because it's the same tokenizer that we have used for fine-tuning Codify and obtaining Plansformer. Then the Plansformer version that we have, which is Codify fine-tuned on 6 different planning domains, is hosted on Dropbox, and you can run this particular cell to obtain the fully trained Plansformer model. Once you run this code, you will get a plansformer.zip file on your local memory in Google Colab. So you can use the unzip command that is shown here in order to uh, unzip the Plansformer file and get the Codify base with the updated model weights which are present in Plansformer. So then we give the model path, which is the Codify base along with the model file. This is the particular folder that we are pointing at. Then we import the same libraries that we have talked about during the fine-tuning phase. We then have the same tokenizer, which is Roberta tokenizer, and the T5 for conditional generation. And we load the model to GPU. There is one thing that is to be noticed here, especially this particular command over here. Since we are not directly importing the model or downloading the model from the Hugging Face library, and we have it hosted on our local system, we want to use this particular attribute, which is called as local files only true, in order to load that particular Hugging Face model. Uh, all right. Next, we move on to the problem, which is being given as input to the Plansformer model in order to generate a corresponding plan. So this particular problem is a compact version of the problem structure that we have seen in PDL previously. So PDL technically has two files, the domain.pdl and the problem.pdl. And we created a condensed version or a compact version of all the necessary attributes that define the environment and the initial state and goal state required in such a compact form, because a small language model that we are using here, that is Code T5, has only limited context length of 512 tokens. So to adhere to that particular context length, this is an approach that we have followed. And in order to visualize this particular problem in a better way, I have created a HTML color coded visualization. So we can see that the goal is mentioned as attributes here, and this is the initial state. There are 4 different actions that we have previously talked about in the blocks file domain, which is pick up, put down, stack, and unstack with their precondition and effects mentioned. So all this constitute the input given to the Plansformer. Now, this is the major block of code where all the functionality of generating the plan is happening. So let's go through each line of code in detail. So the first line basically is tokenizing the provided planning problem using the tokenizer, which is Roberta tokenizer. The tokenizer converts the input problem string into a sequence of integer IDs representing the tokens. The encode method performs this tokenization and returns the IDs as a PyTorch tensor. This tensor is then moved to the specified device, that is GPU that we have been connected to, and set to be of type torch.long, which is the data type expected by the model. Then we have this major chunk of code with a lot of hyperparameters, which we have also mentioned during the fine-tuning phase. So this line generates a plan for the given problem using the fine-tuned Codify model or Plansformer. And here is a breakdown of the parameters that are being used. So the input IDs basically are the tensor representing the encoded input problem. Then we have the number of beams. This parameter controls the number of beams to be used in beam search decoding. Beam search is a technique used to generate multiple sequences in parallel and select the most likely one. Then we have max length. The max length of the generated sequence is set to the length of the input sequence plus 2. This ensures that the generated plan is not too short or too long. Then we have the repetition penalty. This parameter penalizes repeated tokens in the generated sequence. A higher value encourages the model to produce diverse outputs by avoiding repetitions. And we have length penalty. This parameter penalizes longer sequences. A value less than 1 encourages shorter outputs, while a value greater than 1 encourages longer outputs. And then we have early stopping. This parameter controls whether to stop the generation process early based on certain conditions, such as reaching the maximum length or producing an end of sequence token. Then we have a final line, and this line decodes the generated plan from the model's output tensor. It takes the first generated sequence from the generated ID's tensor, assuming only one sequence is generated, and it converts it back into a human readable string using the tokenizer's decode method. The skip special tokens equal to true, which is this particular part, tells the tokenizer to exclude special tokens like padding tokens or end of sequence tokens from the decoded output. Then we can visualize the output from Plansformer for the given input, which is this particular problem, as this, which is a valid plan for the given problem. This is just one particular problem from Bloxwell that we have shown in this particular notebook. But I would encourage everybody to go into the data subfolder of part 4 and in the test samples where we have provided multiple problems that you can test out with and see the performance of Plansformer. You can also change certain action names or object names as per your wish. That would still make sense to a human, and see how this particular Plansformer model either fails or is still able to overcome uh, such minor changes or minor errors in the input and still generate a plan. That is all for this particular notebook. Thank you very much.